All right, everybody, what's up? It's Hutch here, and I'm just going over your Module 1 Proportional Relationships practice test. All right, something to keep in mind. Remember that every single one of these is connected to a lesson in our notes. So if you look back at our other notes in our Module 1, you can access those for support or also some extra practice problems. So follow along. You can skim through at your own pace and just check and make sure you have everything. But really be detailed because you want to do well on this test, and so you have to put in that effort to make sure that happens. Okay. All right, so here we go. Number 1. A truck driver drove 48 miles in 45 minutes. Identify, that's my ratio. At this rate, how many miles can the truck driver drive in 1 hour? Since they're asking about 1 hour, I know they are asking for my unit rate. So this is a unit rate problem. So let's see, 48 miles in 45 minutes. Okay, so one of the things is it's asking about an hour, so I have to be a little bit careful. Remember, 45 minutes, if I'm thinking about a clock, okay, this is 15, 30, and 45. That's 3/4 of an hour, or 0.75 hours. Okay, so this is 0.75 hours. Okay, is this. All right, now how do we find unit rates? We just divide the numerator divided by the denominator, and it equals, and all that is over 1 whole. So let's go ahead and pull up our calculator. I'm just going to use this just because it's a little bit bigger for the video. Okay, so 48 divided by 0.75. And there we go. We have 64, make sure you have your labels, miles per hour. And there's our answer. Okay. All right, let's go ahead and slide over to number 2. Okay, this is also from lesson 1. It says, thunder from a bolt of lightning travels 1/10 mile in half a second. At this rate, how many miles can it travel in 1 second? So again, because it's asking that, I know this is a unit rate type of question. Okay, so I'm just taking note of that as a mathematician. All right, let's get the rate here. So we have 1/10 of a mile. So that's just 0.1, okay, of a mile over half a second. That's 0.5 seconds. And we want to make a unit rate, so we want to change it to 1 second. Okay, how do we find unit rates? We just divide the numerator divided by the denominator, and we get our answer of 0.2 miles per second. Okay, and there you go. There's our unit rate. All right, now we're moving on to the lesson 2 skills. So let's go ahead and take a look at these. A salad dressing calls for 3 parts oil to 2 parts vinegar. So there's my first ratio I notice. Jack uses 4 parts vinegar to 6 parts oil. So we have 2 ratios, and this one is about proving whether or not they're proportional. So remember, we have a couple ways of proving if something is proportional. So let's first set it up. So 3 parts oil over 2 parts vinegar. And let's set it equal because we're saying we think they're equal, but we're not sure. Okay, so we have 4 parts vinegar. Oh, be careful, they're switching them here. Make sure you put them in the correct spot. To 6 parts oil. So you need to be in the same numerator and denominator with the other one to compare them properly. All right, so we have a couple ways of determining if 2 ratios are equivalent or proportional. My favorite is just turn each of them into decimals, do the division, but you could also do means, extremes, and cross multiply. But I'm just going to do the division. Okay, so you just do the 3 divided by the 2. Okay, and let's go ahead and calculate that, and it's 1.5. Let's do the 6 divided by the 4, and it's also 1.5. So we just put our equal sign to show that they are proportional. Okay, so this is a yes, they are proportional. Okay, so you can see how neat I'm trying to be with my work. All right, your next one is a lemonade recipe calls for 1 part lemon juice, 4 parts sugar, and 8 parts water. If we have 4 tablespoons of lemon juice, how many tablespoons of sugar and water will I need? So this is one of those triple ratios. So we can't write it as a fraction. So we have 1 part lemon, and so I'm going to use my ratio colons here. 4 parts of sugar to 8 parts of water. Okay, so that's a 1 to 4 to 8. They're saying we have 4 tablespoons of lemon juice. So here's what I have, 4 tablespoons of lemon juice. How many tablespoons of sugar and water will I need? Okay, so we have a couple options here. I want to look at what the relationship is from 1 to 4. Okay, so what is it? Well, that's a times 4 multiplier. Okay, so if these are proportional, I would do 4 times 4 to create this. And so that would be 16 tablespoons. So it's in the same unit, tablespoons of sugar. Okay, and then we need to look, well, what's the multiplier from either 4 to 8, or you could look from 1 to 8. Okay, the 1 to 8 is times 8. Okay, the 4 to 8 is times 2. Okay, so you could go either way. I'll just do the times 8 from 1 to 8. And so 1 times 8 is 8, so 4 times 8 is 32. Okay, and so we have 32 tablespoons of water. Okay, and so there we go. How many tablespoons of sugar and water will I need? There's my answer right there. Okay, so that's how you handle triple ratios or quadruple, or as many as you have. All right, now we are on to lesson 3 tasks. Okay, Ben paid $12.50 for 25 game tickets, and Ava paid $17.50 for 35 game tickets. What is the constant of proportionality? So now we're moving on to the next thing. So just remember, how do we find constant of proportionality? We find the unit rate, and the top of that is the COP. Okay, so I just need to remember for this, find unit rate. Okay, and then it'll allow me to see the COP. Okay, so there's my steps. So let's go ahead and do Ben first. Okay, and we'll put our cost on top, $12.50 for 25 game tickets. So we'll just do T for tickets. Okay, and let's go ahead and find his COP. So we find the unit rate for him. Okay, how do you find the unit rate? We take the numerator divided by the denominator. So $12.50 divided by 25. And where does that go? We put it on top. So this is 0.5, but you need to write it right. So that's 50 cents per ticket. Okay, so let's go ahead and check Ava's and see if she has the same. I'm assuming it is because it just says what is the constant proportionality. I don't think they would trick us and have one not be that, but let's go ahead and double check. So $17.50 for 35 tickets. What's the unit rate? Because that's how we find COP. Okay, so let's do our numerator divided by the denominator. And look, there we go, 50 cents also. So what is the COP? Remember, the COP is right there. So we need to list it. COP equals 0.50. That's the multiplier for any single ticket. Okay, and there we go. All right, let's go to number 3. The table shows the distance traveled by a runner. Use the table to find the COP. How do we find COPs? We find the unit rate, and the top of the unit rate, the numerator, is the constant of proportionality. So let's do this right here. We have miles per hour. Okay, so there's a numerator and my denominator. So let's go ahead and test it out. Okay, I can either set it up down here like this, or just see that it's sort of set up like that already. So I think I'm just going to treat it like that and do my division for 0.55 divided by 0.5. And we get 9.1, but now's where you need your labels, miles per 1 hour. Okay, so let's just go ahead and test one more to make sure this table is proportional. Okay, it should be because it's saying find the constant proportionality, so I think we're done, but let's just test it one more time and do our miles per hour. 13.65 divided by 1.5. Yep, we got 9.1 miles per 1 hour. So where's my COP? It's on top, but I need to say it to answer the question, is 9.1. Okay, all right, let's go ahead to the next lesson. Your next lesson is lesson 4. Okay, we have the cost of pumpkins is shown. So let's try to see what this one's about. Graph the relationship on the coordinate grid and tell whether the pumpkin is proportional to the number bought. Okay, the cost of pumpkins. All right, so this is one of those where we graph it and we remember what does the graph have to look like to be called proportional. Okay, so here's my ordered pairs. Okay, and let's look. Pumpkins is here. Remember, this is X and this is Y. So X is pumpkins and Y is cost. We always want to label it. Okay, and so my first one is obviously 0, 0. My next one is 1, 4, and remember that looks like this. Ordered pair 1, 4, X and Y. So go over 1. Pigs have to run before they can fly. All right, and then ordered pair 2, 8, 3, 12, and 4, 16. Okay, start at 0, pull your line out, and there we go. All right, tell whether the cost of pumpkins is proportional. Yes, it's proportional. Now, it doesn't say how do you know, but you should be able to know it's a straight line and it goes through 0, 0, okay, or the origin. All right, number 8. The total cost of online streaming is proportional to the number of months. So they're already telling us it's proportional. The question is, what is the COP? Okay, so we know COP. How do we find COP? Well, we look at the unit rate, and the top of a unit rate tells us the COP. Well, where's the COP in a graph? Well, the COP is where, when we have y over x, x equals 1. Okay, that's the unit rate, right? When x equals 1. So whatever y is, this is our COP. So let's look where x is 1. So this is where x is 1. So where is y? Well, right here. And it looks like it's probably at 15. Okay. But let's go ahead and look at another ordered pair just to make sure. So I think it's $15 per 1 month, but let's check. Okay. So I'm going to go to this one. This is ordered pair 460. Okay. And let's go ahead and find the unit rate. Well, how do we find the unit rate? We know that we do y over x. Okay. So 60 divided by 4. So what is it for 1 month? Let's go ahead and test because this is 4 months and $60. So 60 divided by 4. Yep, the unit rate is $15 per month, and we proved it with another ordered pair, which is really important. Okay, so what is the COP? COP equals 15. Okay, all right, on to the next one. Here we go, lesson 5s. Okay, so let's see what lesson 5s are about. Okay, the total cost of renting a cotton candy machine for 4 hours is $72. What equation can be used? Okay, so now we're making the equation for the proportional graph. And remember, what is the equation? Okay, that equation remember it was y equals k times x. Okay, so that's what we have to make. And what is k? Remember, k is the COP. And you know how to find a COP. We have to find the unit rate. Okay, so here's our original ratio. Okay, is 4 hours is $72. $72. Let's look because there's labels. So the total cost is y, and x is the hours. Okay, and remember to find the COP, we're going to do y over x to find the unit rate. So we have $72 for 4 hours. And what is it for 1 hour? Because that's how we find the COP, or the variable k. So 72 divided by 4 is $18. Okay, so now I know. Remember, we made this label. We said this is the COP, and it's also the variable k. So let's go ahead and plug it in now. So y equals 18 times x. So what equation can be used? There we go. We created the equation. So anything we put in x, we multiply by 18, and we will get y. That's what that means. All right, let's do this last one for lesson 5 here. Evan earned $32 for 4 hours of babysitting. So there's a ratio for us. What equation can be used? So we have to do another equation to model his, total earnings, y. So total earnings is y, and x is hours. So let's label that. That's a tip I told you about a lot. It says, what is the unit rate? So we know we have to find that, okay? So that's going to be step 1, really, because we know to make that equation, we need the unit rate, which gives us the COP. Then we need to make the equation, step 2, and then it says graph it, so step 3. Notice how I'm noting that I have 3 things to do because I don't want to lose any points. So let's find the unit rate. To find the unit rate, remember we do y over x, and my y over x is $32 per 4 hours. So let's make the unit rate. How do we make unit rates? Numerator divided by the denominator. That answer goes on top, and we need to make sure everything's labeled. So here's my unit rate, and remember, what is this? This is our COP. It's also the variable k in our equation. So what is the equation? Well, the equation is y equals k times x. So now we just plug in the information. Okay, so we figured out the unit rate, so that one's done. Okay, and now let's create our equation. So y equals, k was 8 times x. So there's our equation. Now I need to graph it. So one of the ordered pairs I already know is, I know ordered pair 432. So I can go ahead and put that in. So over 4, because pigs run before they fly. And let's see, 24, let's look at the intervals, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. 32's off the charts anyway. So I can't use that like I did in my notes or homework. So I'm going to have to plug in something for x in my formula and see what pops out for y. Okay, so let's pick something like 2 for x. Okay, so I'm going to say y equals 8 times 2. And whatever x we put in, we can multiply by 8, and it'll tell us what y is. So for this one, y is 16. So I just created ordered pair 2, 16. Okay, so let's go ahead over 2, up 16. So we have, it goes by 3s, 12, 13, 14, here's 15. So 216 is probably right there, a third of the way up. Okay, now technically I don't need any more ordered pairs because I know it goes through origin 0, 0. But let's do one more just to practice, okay? And maybe we try hour 3, okay? So I'm going to do y equals 8 times 3 this time. So let's see what the y would be. Okay, so y equals 24. So I just created the ordered pair 324. Okay, so let's go over 3, up 24, and there we go. There's our second ordered pair. And let's go ahead and draw our line, starting at 0, 0, come up, and there we go. We graphed our equation. Okay, all right. Last two is information from lesson 6. Okay, of the 50 band members, 8 play trombone. There's my first ratio, my OG. If there's 180 band members, predict the number of students who would play trombone if the relationship is proportional. All right, remember, we have an original and they're asking us to predict. Predict makes up, we make a proportion. So 50 band members, 8 trombones, set it equal to what we're trying to predict. So put in your 180 band members, and this is your X, is the amount of trombones. Okay, so remember we have 2 options for solving proportions. Option 1 is find the multiplier, multiplying by what whole number. So how to do that? 50 times what equals 180? So I'm going to do 180 divided by 50. Oh, nice, I have a good multiplier. Times 3.6 over 3.6, because that's times 1 whole, and it doesn't change our fraction, the fractional value at all. Okay, so 8 times 3.6, and we get 28.8 trombones. Okay, which we can't really have 28.8 trombones, and so if we had 80 band members, we would have to say we would have about 29 trombones, okay? Because these are really people and we can't commit a crime here, okay? So that ends up being our answer, okay? Let's look at your last one, number 12, which is also lesson 6, so that's creating a proportion. A 12-ounce package of Oreos has 28 Oreos in it. So I found my original ratio. There's my OG. About how many Oreos would be in a 26-ounce package? So they're asking us to predict again, okay? So let's do 12 OZ, okay, over 28 Oreos. Set it equal to what we're trying to predict, okay? And we're trying to predict, well, what if there's a 26-ounce package? So I'm going to put that in the numerator with the ounces. And the bottom is my X. So we have 2 ways to solve proportions, right? Find the multiplier. So let's check that first. So 12 times something equals 26. 26 divided by 12. Oh, it's a repeating decimal. So you cannot do the multiplier method when you're getting a repeating decimal. So we have to do means extremes. Okay, and on your test, one of them will be a means extremes as well. So 12 times X, okay, so cross multiplying, so we have 12 times X is 12X, equals, now let's do the next one, 28 times 26, and you have 728. Now we need to isolate the variable and get X by itself. So right now this is a 12 times X. So I'm going to divide by 12, do the inverse operation. That makes 1 whole, and so we have X equals whatever that is, 728 divided by 12, 60.6 repeating. Okay, but it says about how many Oreos? Okay, so we can say about 61 Oreos would be in a 26-ounce package. And there you go. Okay. All right. Those are 2 problems from every single lesson. And your test is going to be a perfect imitation of what you see here. So if you had any trouble with any of those, now devote some time tonight going back to some of those notes videos on our YouTube playlist that's on Schoology, or you can take a look at your notes or the homework or anything like that, and even erase some of your homework problems or the notes problems and try them for extra practice on your own. All right, let me know if you need any help, and good luck.